Hi everyone, and welcome to this video for P80-105, a course on data science. This is the first in a collection of 2 videos on data wrangling, some additional information about reading information from the web and how to work with strings and factors. Today we'll talk about getting information from the web. I'm going to start by giving an introduction using slides, and after that I'll demonstrate the material in a screencast. Feel free to skip around to the parts of the video you find most useful, and as always, I encourage you to code along with me to get the most out of this. All the material is available at p80-105.com, and there are links in the description below. Awesome, let's get started. Right, so let's talk about getting data from the web. In general, there are 2 major ways that you might get data from an online source, and we're going to talk about each of these in turn. The first of them basically is that you are looking at a web page and you see some information there that you want to scrape. You've gone to a website, you've gone to IMDb, you've gone to Amazon, you've gone to Wikipedia, you've gone somewhere and you see a table or you see some other content and you say, that'd be great if I could get that into R, right? And that's the idea there, is that you are looking at something that you want to see on a web page and you need to scrape out the stuff that you need from that. We're going to talk about that first. The other way that you might get data from an online source is when there is a dedicated server that is holding data, not printing it online, not putting it on a web page. It's just a server that holds the data that you need, and you want to interact with that server by submitting a request and saying, I would like you, please, server, to send me this data, and it will send that data back to you. And the difference here is that you're not really looking at the data, you're not sort of extracting it, you're interacting with some server in a way that allows you to query a particular data set and to get that back. And here you're sort of, it's less like something that you might see in a table, but it's more like publicly available data sets. So New York City has a big open data repository. The US government has a big open data repository. There is a Star Wars API. There is a Pokemon API. There are APIs, these ways of interacting with servers to get data. There are APIs that hold data for a wide variety of sources, and we'll talk about that path second. So we got to talk about how you're going to scrape data from a web page. And to do that effectively, we sort of have to talk about what a web page is. And I know you're sitting there thinking, like, I know what a web page is. I live on the internet. This is easy. But I want to be a little bit more clear about what exactly is happening here. So when you navigate to a web page, effectively you're communicating with the server. Your computer is saying, please server, send me the stuff that's on this web page, and what gets sent back to you is then rendered by your browser. So the web page that gets rendered by your browser usually combines 2 different things. There is underlying HTML, and then there is a CSS file that adds some styling that changes the font colors in the background and things like this. But the web page that you look at combines the HTML with the CSS. When you are trying to extract data from a web page, basically you want to look at that HTML and just pull out the stuff that you're interested in. And so in that sense, if you have gone to a website, in some sense you've already gotten the data. It's just formatted in a way that you really can't work with particularly well. You need to do something to extract from a very long collection of HTML. You want to extract out the stuff that you actually care about. And so that's really the challenge with scraping, is to get the information that you need out of an HTML file that you already have. And this, I like this collection of slides, if you can track it down, that talks about getting data from the web. And so here is sort of showing exactly what happens here. You have your computer with a web browser over on the right. Your web browser sends a request to a server, and that server sends you back an HTML document. An HTML document by itself gets rendered in a pretty static way, a pretty like clean way. There's just like some text and maybe some links and things like this. But when you tack in the CSS file that goes along with that HTML, you get something that's a little bit more clear, right? You get something that actually looks like the website that you're interested in, with all the styling and the stuff that goes along with this. So as a result of this, very often when you are looking at something in HTML and you see like a table or some text and you're like, that's what I want to get, very often in the HTML there is some CSS identifier, a piece that says, okay, this is a table, style it like a table, or this is a list, style it like a list. And so often what you end up needing to do if you are trying to extract particular information from a website is to get the HTML and then figure out what CSS identifier, what CSS tag is going to say, this is a table. And you say, go through that HTML, pull out the table, and then work from there. And so that's really sort of the process that you use. Now, you might be thinking, oh man, I really do not want to learn HTML, and I really ultra don't want to learn HTML and CSS. And you're right, you don't, that's fine. So when we start talking about how you're going to do this process, what we're going to use is the CSS selector. And in particular, we're going to use selector gadget, which I hope everybody knows about inspector gadget. I'm just like crossing my fingers about that. So how does the CSS selector work? All right, so I started out by saying, when you are scraping data from the web, very often you can navigate to a website and see what it is you care about. So the CSS selector says, go to this website and see the thing that you care about and click on it. And hopefully that will give you, in the little window in the selector gadget, it will say the CSS tag for this thing is this. And you can copy and paste that over into R and extract that from your HTML page. Sometimes that CSS selector, that CSS tag, applies to a bunch of things on a page, and you have to say, I mean this, but I don't mean this, and I do mean this. Right? You click around a little bit, selecting and unselecting pieces that you want, and the CSS tag, the CSS selector, is refined. And so then again, you sort of are left with the CSS tag that uniquely identifies the thing you care about, and you go over to R and you say, please give me the HTML, and then extract out all of the elements from that HTML that has this tag, and then great, you're sort of from there more or less off to the races. There's a little bit of processing that you have to do after that, but that's sort of the big step that you need to get through. So the package that we're going to use to do this is the rvest package. That's a pun. The rvest package is the one that is designed to facilitate web scraping or pulling data from the web. So the idea, the process that we're going to use is find a website where you want to get data, read the HTML, not into a browser, read that HTML into R using read HTML, and then use HTML nodes and some CSS selector that you've identified to extract the nodes from that HTML that you need. And then once you've sort of said, here's my HTML, here are the nodes that I care about, you're going to extract content from those nodes using a function that will either convert HTML to text or HTML to a table or something else beyond that. And if everything goes smoothly, fingers crossed, if everything goes smoothly, well, then you've got stuff that starts to look like data that you can use. And we'll see this in action in the screencast. So I'm going to switch gears just a little bit and talk about APIs, right? So again, scraping data from the web, you see a website and you really want to, get the viewers in the Game of Thrones season finale. You really just want to pull that data set in. That's scraping data from the web. I'm going to talk about APIs in a sort of different way, where again, here what I'm thinking about is that there is a server that holds the data that you want. You're not going to look at it on a website, but you do want your computer to contact that server and request specific data. And the way that you do that process is through an API or an application programming interface that allows you to send a specific request to a server, and the server processes that and sends it back. The good news is that APIs often can be accessed using this sort of web-based technology. You're going to sort of, in the same way that your browser sends a request to a server, you're going to use R to send a request to a server. That's the good news. The bad news is that APIs are not super standardized in terms of how you might interact with them beyond that, or the structure of the data that they might send back to you. So here I mentioned the Star Wars API is going to behave very differently than an NYC Open Data API. And the challenge there is that since each API is a little bit different, if you need to refine a request for that server, sometimes it takes a little bit of digging. The data that comes back to you often requires a little bit of processing to turn into something useful, and that's not always an easy part of things. In really useful cases, in easy cases, I'll say, what you end up with is making a request to a server for a data rectangle, and it sends you that data rectangle back essentially as a CSV. And then you're sort of like in an easy case. There are a lot of data sets like this on the NYC Open Data. There are a lot of data sets like this on data.gov. Those are going to be data rectangles, and they're relatively easy, but sometimes it's not. So here I'm sort of repeating some of the things that I've said a moment ago. Web APIs are going to be accessed using HTTP. That's the same thing that your browser uses to make a request to get a web page. There are a variety of tools for constructing requests in the httr package. That's the one we're going to use. And we're going to focus in particular on GET. Get is the thing that says, please get information from a server, not trying to put information back on a server or modify data on a server. We are just going to focus on getting data from a server. And like I say here, you can modify your HTTP request with parameters if that API asks or requires you to do that. And we'll see an example of that shortly as well. So again, sometimes the API is going to give you a CSV, and that's great. And you might sort of think to yourself, well, if I can just get a CSV from an API, can I also just get a CSV from a web page? And sometimes the answer to that is yes. Sometimes you can go to data.gov, and instead of using the API, you can sort of click around until you find a download CSV button. The reason that you might nonetheless want to use an API first is for reproducibility, so that you can say, not I went to this website on this date and clicked this thing, but to say, here is the exact parameter that I used, here's the exact query that I made, and here's what was returned. It's also true that this is helpful when data sets get updated from time to time, so that you don't always have to go to a website and click download and then copy that into some folder. If you know a data set is going to be uploaded periodically and you want to make sure that your reports react to that, having an API query is a quick and easy way to do that. So in lucky cases, you're going to get a CSV from an API, and I still think it's worth understanding how to get that using an API rather than just saying, I went to a website and downloaded this thing. In less lucky cases, you might get from an API something called a JavaScript object notation or JSON file. And JSON files are their own structured format. We're not going to spend a huge amount of time talking about this. Other than that, it gives you a way to store data that are not easily formatted into a data rectangle. If you want to have a row that's got sort of a branching structure here and then subfields and other things over this way, something that isn't really just easy to put into a rectangle, you might get a file out like this. And if you do, often you have to spend some time extracting the pieces that you need from that data object to create your data rectangle prior to working with this. And we will see an example of that, but not really dig into it too much. The talk about APIs and the talk about getting data from the web via scraping and things like this, it sort of suggests, and this is true, that reading data from the web is a critical skill, because often the data that you want to use are available online rather than in some spreadsheet that somebody has already made. But getting data from the web often takes a little bit of work. And then once you get data from the web, there is often still a little bit of work to figure out how you're going to organize it to be actually what you need. So this is important, and I hope you either recognize that now or come to recognize this over time. It's important to be able to go out and get the data that you want and not just rely on somebody else to generate a CSV and send it to you. But it does take a little bit of work to get this operating. And with that, I'm going to switch over and we're going to do a screencast and see how some of this works. All right, we're going to get some data now. So what I'm looking at is RStudio. I have, in advance of this video, created a data wrangling to GitHub repository in our project. That's what we're looking at here. I've already gone ahead and opened that infrastructure, set everything up, and I created a reading data RMD file. We're going to be reading data from the web, renders to a GitHub document, and I've got my usual setup here. I don't know if we're going to be making any plots today, but just because I always include this code, I've got this stuff that sort of sets up plots the way that I want to. I'm loading the tidyverse here, and I'm also loading the two packages that are new that we're going to be using today, rvest and httr. Those are both, I think, I would sort of think of these as tidyverse adjacent, in the sense that the folks who develop these often overlap with the folks who develop these, and there are similar sort of workflows in mind for both, but they're not sort of in the core tidyverse. If you want to use functions in rvest and httr, you have to load those separately. And rather than using like rvest double colon some function, since we're going to be using a few functions for both of those, I'm gonna import both of them. What we're going to be doing today is first scrape table, and that's scraping a table from a website. And so let's sort of think about what table I'm going to be looking at. I'm going to go here at p8105.com. I'm going to go to data wrangling 2 and then reading data from the web. And this is where we're going to get a sense of what it is we want to extract. So here I want to extract a table, and we're going to take a look at data that comes from the National Survey on Drug Use and Health. And let's just sort of see what this looks like. So when I open this up, I see great up at the top, National Survey on Drug Use and Health, comparison of 2013-2014 and 2014-2015, population percentages, 50 states in the District of Columbia. And I'm looking here at this first table. I'll sort of scroll down. There's a table 2. There are a lot of tables on this page, and there's some information down here at the bottom about the methodology used to estimate the Bayes significance level for the null hypothesis. If we wanted to look at those significance levels, we would probably need to read some of that. We're not going to worry too much about that. I'm scanning down just to sort of see there are a total of 15 tables here, and we're just going to focus on the first one. Table 1, marijuana use in the past year by age group and state, percentages, annual averages, and p-values test for differences. Okay, we've got state, total US, some regions, and then it looks like the states in alphabetical order, Alabama, Alaska, up through Wyoming, and then there's this collection of notes down here at the bottom. And if I look here, I could see, for example, 12 to 17, 2013, 2014, and 12 to 17, 2014, 2015. It looks like we have, for example, the District of Columbia, 20% give or take of 12 to 17-year-olds reported marijuana use in the last year in the District of Columbia, and that was down to 16.5% of the same age group in the following year. And you can sort of see there are different, we've got a lot of numbers here, we've got a lot of different age groups, we have a column for p-values, but we've got some stuff going on, and the short version of this is I might actually want to do something with this data set. I might actually care about this data set beyond just being able to look at it and say like, okay, great. So the goal that I have here, this is a prime candidate for scraping data because I can see everything that I want, and what I really don't want to do is like try to copy and paste this into Excel. That I think would be a disaster and it would take forever, and I don't want to like spend the next 3 hours typing in numbers one at a time. This is the data, I can see it, I just want to have this in R in a tibble so that I can make my own plots. Thank you very much. So that's really what we're going to be working about or worried about now. So let's figure out how we're going to do this. So I'm going to say first, I want the first table from this page, and I'm going to include a link here just to make sure that I know what I'm talking about. Let's copy my link over. Okay. And now I want to start doing this. Now, the process that we described in the slides for getting data from a website is sort of the following. First, I got to get the HTML, and then once I have the HTML, I need to extract the particular kinds of elements from that HTML that I care about, and then I probably have to do some additional processing to get to where I want to get. So I'm gonna follow those few steps. And the way I'm gonna do this for now, I'm gonna define my URL just because I find it easier to define a URL in an initial thing by itself. So this is just now an object that stores that whole website address, and I'm not worrying too much beyond that. Now I want to read in the HTML, so I'll call this the drug use HTML, and what I'm going to use here is a function from rvest called read HTML. I guess I didn't actually load those packages yet, sorry. All right, so I'm going to read the HTML from that link, okay? And what's happening in the background here is roughly the same thing that happens when I navigate to a web page, but now it's just R navigating to that web page, and instead of showing what it sees, it's just copying down whatever the server sent. And you might think that like nothing has happened, but if we check this out, if I just sort of try to print this, it's going to say, all right, you have an HTML document, it's in English, you have header information that's got some link and some other stuff, you have some body information, no script, something, your browser's JavaScript is off. This is kind of a mess, and if I tried to dig into this, I would just see huge amounts of HTML. So I'm not actually going to worry about what this is too much. I'm just going to sort of be happy that I seem to have an HTML document, right? I seem to have like read in the HTML stuff. Okay, so this is read in the HTML, and now extract the tables. Okay, and when I say table or tables, the next step in this, I've got my HTML and I need to pull out the stuff that I want. And I've talked about using selector gadget to do that. It turns out the CSS tag for HTML tables is common enough that I'm just going to sort of guess that what I'm looking for is a table, and I'm going to leave it at that. I'm gonna hope that this works the way that I want it to. So let's take a look at what happens if I take my drug use HTML and I'm going to pipe this directly into my next rvest function, where I want to use HTML nodes to extract the HTML nodes with a particular CSS tag. And I'm going to define the CSS as table. And again, this is sort of based on knowing that a table in HTML is often indicated using table. So great, I've done that. Now, what this has pulled out is, again, looks like maybe terrible news, but actually pretty good news. And the reason I say it looks like terrible news is that this is still not a tibble, but it's getting closer to being what I want, in the sense that this first element is a table. It's got some class, it's got some border, it's got some other CSS stuff, it's got a summary, and it's got a lot of other information. It hasn't been converted to a tibble yet, but I am at least getting the first element here looks like a table, and the second one does too. And I've got 15 of these things, which, no coincidence, there were 15 tables in my website. And what I have done here is, from the HTML, extracted all 15 of those things. Okay, so I've got now all 15 of my tables. They're still sort of in this format that isn't super useful for me. And I need to do some step to convert that table to something that looks more like a tibble, more like a data frame. Okay, so this is going to extract the tables. I'm going to say, since I've got this collection, I've got 15 of these, I really only want to work with the first one. So I'm going to focus on the first one. And I'm not going to get into too much about this piece, but if I have a list of things and I want to select the first of those things, I'm going to use first, right? And the reason I'm not getting into this too much is that I don't want to focus on how our worries about vectors and lists and things like this. I'm just going to say I want the first one here. The first function is a helpful one to sort of know about for reasons like this. There is also an nth one if you want the second, third, fourth, or fifth, and a last one if you want one of those. I just want the first one, so I'm going to take the first one, and the first one of these things is now starting to look more, well, if you stare at it for a while, it's starting to look a little bit more like what I want. I have a table, table 1, span class, bold title, I don't know, marijuana use in the past year. That's starting to sound like what I want. By age group and state, percentage. It's got some other stuff, but this starts to look like what I want. Marijuana used in the past year by age group and state. All right, I'm getting the table that I want. Now again, it's still formatted as HTML, so I need to do something that parses this into something that's like text. And again, the rvest package is going to try to help us out here. So you can often parse HTML from a table or from text to strip out all the HTML stuff and just get the pieces that you want. So I'm going to use HTML table and see what I get. So it's taking that, it's printing it out, and it's done something that looks, gosh, just awful, but is actually, believe it or not, not so bad. So if I view this, I'm going to see that it's actually done a pretty good job. I've got state, I've got 2012 plus 2013 and so on. My column headings look to be about right. And then I've got total US, and I've got the fraction that goes along with this. I've actually got the data that I want. The problem is that this first row, this note, for whatever reason, this note has been copied into the first row of every single column that I have here. That's a little bit frustrating. It's not the end of the world. And so what I'm going to do is just get rid of that first row. And there are a couple of ways that we might do this. We might filter anything that has note in it. We might do some other sort of step like that. I'm just going to use this slice function that can be used to access specific rows in a data set. And I'm going to slice, I'm going to remove, using the minus sign, the first row from each of these. Let me sort of take a look again at what I end up with. This is starting to look more like it. Can I scroll up? Yeah, this actually now looks pretty close. It's not a tibble though, so I'm going to convert to a tibble. And now I've actually got, gosh, just exactly what I wanted. I've got state, I've got 12 plus in 2013, 2014, and 2014, 2015. I've got all my columns, I've got all my stuff. And we've had to do a little bit of work to get here, but I guarantee you this is less work than trying to copy and paste this into Excel or trying to generate this data in some other way. So I'm gonna save this. This is my marijuana use table. Save this as an object. If I really wanted to use this, there is some additional work that I would have to do. Each of these columns is being stored as a character, and the reason is that it's got some numbers followed by an A or a B. Those superscripts or subscripts are being copied in. I need to do something to kind of get rid of those. This is also probably not well formatted as a tidy data set. There's some other stuff that I would want to do. The column names are sort of bothering me. There's work that we would have to do if we wanted to use this for something, but at the very least, I have pulled this data set in from the internet, and I think that that's just a pretty neat thing. There are some other examples that you might use. Again, often if you need to pull in tables, extracting HTML and then asking for the tables and then trying to figure out which table out of a list of 5 or 6 or 7, that's going to be often the process that you need to use to generate a data set or to import a data set, scrape a data set from a table on a website. So this is the marijuana use table scraping. Okay. All right, so let's shift gears just a little bit and try to get a non-table collection of data from a website. All right, so let's go back. What is the example that we're going to use? We are going to go to, let's see, the Star Wars movies IMDb page. Okay, so here they all are. I want to look at the title. Let's take the rating, 6.5 for episode 1. Okay. And let's say the gross money. Let's say like those are the things that I want. I would like to have a data frame that says title of the movie, star rating, and how much money it made. You could maybe link in, I think, the runtime here if you were interested. Maybe that's something that we'll take a look at. But let's sort of see if we can get at each of these things. Actually, let's do title, runtime, money rather than stars. So the question is, like, I've got this HTML and I know how to read in the HTML, but I'm going to have to worry about the selector process. And I'll worry about the selectors in just a second. So let's go back over here and say Star Wars movie info. I want the data from here. And again, I'm going to make this a link. Fantastic. The first step that I'm going to use again, I'm just going to define my URL in quotes. And the first step that I'm going to use is, let's read in the HTML. Star Wars movies, HTML is read HTML, whatever comes out of my URL. All right. And again, I need to make sure I'm getting the right URL here. All right, and so let's take a look. Okay, HTML document, some stuff. But it's got some HTML, and I'm pretty happy with this. Now, what we did ahead is, let's see, let's grab elements that I want. What we did with the table was just said, give me the tables, and that worked well enough. Unfortunately, I at least don't know off the top of my head what CSS tag IMDb might use for movie titles on the page that we're looking at. So here, what we need to do, I'm going to sort of focus on titles first, and I'm going to make a vector out of these. What I want to get, first title, second title, third title, fourth title, that's what I'm looking for. I need to get the Star Wars HTML, and then I need to extract something from here. I need to get the HTML nodes, but I don't know what the CSS tag I'm going to give it is. It's not going to be tables, it's going to be something else. And that's where selector gadget comes in. So I'm going to do a little brief aside over here. And let's see where I link to selector gadget up here at the top. So let's go to the selector gadget page. Selector Gadget point and click CSS selector. It looks like it's from 2015. It probably is. The last update is August 2013. Doesn't matter, still works. There is a Chrome extension, or you can drag a link to your bookmark bar. And in fact, I already have this Selector Gadget right up here in my bookmark bar. And you can watch this video if you want to. I'm going to explain how Selector Gadget works as well. So if you want to see multiple examples, knock yourself out. But the main idea is you're going to go to selectorgadget.com and you're either going to get a Chrome extension or you're going to put this in your bookmark folder, and we're going to see what happens. So how does this work? Okay, I need to extract some bit of CSS that is going to tell me whatever this movie title is. And ideally it would tell me not just this movie title, but it would get me all of the different movie titles. So I'm sitting here, I'm looking at what's going on, and I'm going to click Selector Gadget, and it loads for a minute, and it says no valid path found, clear, toggle egg, whatever, right? It's got some stuff. And as I sort of scroll through here, it's highlighting boxes of content somewhere on this page. And if I sort of hover over this, it looks like it's telling me something about it. It's like giving me an image here. If I hover over this, it's like a whole movie bit. And if I hover over here, it's giving me lists and other things. So I'm going to click on the smallest box that includes the thing that I actually care about. I'm going to click right here. It's not taking me to a link, it's just saying these are the objects that are highlighted by this CSS selector. And it looks like it's gotten the titles, but it's also gotten everything else that is a link. And I don't want everything else that's a link, I want this thing. So now I need to click stuff that I don't want. And I click this one, and the CSS selector has learned I want these titles, but I don't want other things that show up as links on this page. Okay, so all my titles are highlighted. Okay, nothing else is, right? And then down here in the CSS selector box, it says the CSS tag that I want is .lister item header A. And I'm going to repeat this process just real quick right now to see how this works. So here I am again, same page. I'm going to click Selector Gadget, and let's say I click on this title. And again, the CSS selector is saying every link A is used as in HTML to indicate links. It's saying you have selected every link, and I'm saying I really don't want that. And it is now saying, all right, the CSS selector that is unique to movie titles is lister item header A. Okay, whatever you say, Selector Gadget. I'm going to copy and paste this. And I'm going to go back over to R, and I'm going to say the CSS tag that I want is just copy and pasted from Selector Gadget. And let's see what this does. It's embedded things in HTML, but it looks like it's kind of worked. I've got a list of 9 movies. There are 9 movies in the Star Wars movies collection. It's got this link HTML business, but then it lists out Star Wars Episode 1, Phantom Menace, Attack of the Clones, Revenge of the Sith, and so on, right? So I actually have pulled out the HTML elements that I care about. And I now need to extract from this HTML list. I just want the text here. So instead of HTML table, I think I used above, I'm going to use HTML text. It's going to convert an HTML object to just the text that's included in there. And let's see what we end up with. So now I've got a vector in R just floating around, a vector that has Star Wars Episode 1, Phantom Menace, Attack of the Clones, and so on. I pulled out the data that I care about. So I'm going to see another couple of quick examples here. Let's do the gross revenue vector using a very similar process. In fact, I'm going to copy and paste this. The only thing that needs to change over here in Selector Gadget is that now I want gross revenue. I want to find this number. Well, okay, let's Selector Gadget it up over here and click on that number. And I don't want this, and I don't want this either. And it looks like now it's highlighting the gross revenue in each of these. Somehow I got this too. It's gotten the gross revenue in each movie. It doesn't look like there's anything else that's highlighted on here. So I would never in a million years have guessed this CSS tag, but it says the CSS tag is text small colon nth child parentheses 7 space span nth child 5. Great. Copy and paste over here. Put that in as the CSS tag that I need. Run that line of code, and let's see what happened. Now I've got gross revenue vector, 474.5, 310, 320, and so on. And that looks, I think that's about right. 475, 310, 380. Yeah, all right, so we're pulling it in. Again, the point is that I don't really care about what the CSS is. I just want the CSS selector to tell me what this thing is. And then just to sort of wrap this up, let's do runtime vector. I'm going to do the same thing where here now, instead of the runtime or the title, I want to know how long were these movies. So let's go back. We're going to CSS selector. Runtime is 136 minutes. Oh, this time was pretty easy. Look at that. There is a CSS tag specifically for runtime. Okay. Let's try that. All right. So again, now I'm saying go into the Star Wars HTML, find the HTML nodes that are tagged with runtime, pull those out, and convert that to text. If I just ran these two lines, I'd probably get a mess of HTML. I get something weird, fine. But if I run this whole thing, I get all the text that I care about. So I'm going to run this. Now, it does, I got to be clear, it sort of bothers me that I have created 3 vectors. I've got a vector for titles and a vector for revenue and a vector for runtime. So I'm going to do a Star Wars movie data frame just to pull all of these together. And let's say the title is whatever's in the title vector, and gross rev is in the gross rev vector, and runtime is in the runtime vector. No, I didn't save it. I'll just run the whole code chunk. Okay. So now I've got a data frame, a nice fancy little tibble here. Star Wars Episode 1, Phantom Menace, was 136 minutes long and made nearly $500 million. Some of these movies made a lot of money. Okay, so the good news here, again, like the point that I want to make is that it is possible to get data from the web. If it's in a table, that's super easy. If it's in a just scattered around on a web page, you can still do it. You have to work with CSS selectors if you want that to work, but it is possible, and you can use that to create potentially interesting data sets. Here we've looked at IMDb. You can get other data from online sources in a way that's interesting. We will, in some future videos, we're going to see some other interesting examples there. We'll get movie reviews from Amazon or product reviews for Amazon or something like this. All right, so that's all we're going to do for scraping data. So I'm going to go ahead actually and knit. I don't need that anymore. Knit. Fantastic. All right, so what we're going to do now is switch gears a little bit and focus on APIs. Now again, APIs are servers that somebody else has set up to make my life easier in terms of getting data. I just have to make a request to that server in a way that the server understands. And we're going to start by using some relatively easy examples here. Relatively easy, again, is a boy, that's really relative. And let's see if this is opening. Takes a little bit. So I'm going to NYC open data at data.cityofnewyork.us. And what I've got here is some information about a data set. This is brief history of water consumption in New York City based on New York City census. This is a small data set that has things like the year, New York City population, water consumption, and per capita water consumption. So I've got 1979 New York City population, capita, things like this. And it's showing data here. I guess maybe you could even try to scrape this, but that sounds awful. We're not going to do that. We're going to use the API to get this data set. Now again, this is one of those examples where you might think to yourself, couldn't I just download this using the export button? And you probably could, but both as a learning exercise and also because going to this website and clicking the export button is probably not the most reproducible way to deal with this. We're going to focus on the API here. So the API here says, access this data set using the SODA API, so CRADA Open Data API. There's an API, and SODA is the one that we're going to be using to interact with this. And it's telling us here the API endpoint, if we want to extract this as a JSON file, and I don't want to do that. I'm going to extract this as a CSV, and it's got here the API endpoint, City of New York resource, some character, something. I'm going to copy this. Okay, that's the thing that I want to request. So let me get some water data from API. Okay. So the water data that I want to get, let's say NYC Water. I want to interact with this API, and the process that I need to use is submit a request to a server that says, please go ahead and give me the data that you have. And so in httr, the package that we're going to be using to interact with APIs, there is a function called get. And get says, tell me the URL, tell me the API endpoint that I care about. And if you have other things that you need me to communicate to that API, we can do that too. But for now, I'm just going to say, please go get the data from this API endpoint. Okay, so let's see what happens here. It's worked mostly. What's happened again is that it sort of has some information about the process that was used. We have a response from this endpoint on a particular date with some status. It's given us a CSV and it's done some other stuff. And then it's actually showing us the CSV. We have comma separated values, year, comma, New York City population. These are the titles. We've got the actual year values along with each of these, but it's just sort of sitting here as like real CSV stuff. So in the same way that we got HTML and then we needed to parse that HTML to go from a table in HTML to a tibble that we can actually work with, we have to do some extra step here. And there is a content function in httr that will try to parse whatever's coming out of this. And if you just sort of run this, it does know, it recognizes that content as a CSV. You can be a little bit more specific about the type of content that you want. Here I want to parse whatever's going on. You can be more specific about what comes out of this, but basically we're going to get the data from the API, and then we're going to need to parse that data somehow to turn this into a data set that we actually care about. So again, here, using a couple of lines of code, I went to the API operated by New York City, and I requested a very specific data set, and that data set was sent back to me. And that is pretty fantastic. I guess I will point out real briefly what would happen here if I did NYC Water and I got this rather than as a CSV using the JSON file structure. I get the same data, but if you the thing that I'm pointing out here is that the structure of this JSON file type is very different in the sense that I've got an open bracket, and then I know in the first data collection, everything in this first open bracket refers to the first data point. The year is 1979, comma, the New York City population is this, the NYC water consumption is this, right? So it's got the same data as existed in the CSV file, it's just structured differently. And one of the reasons that people will sometimes use a JSON file thing instead of a CSV is if you wanted your second variable to include not a single number, but a collection of things that could then be expanded or contracted, well, then you need something that's a little bit more flexible. And we're not going to worry too much about that. I just wanted to point out for now that you can request this as a JSON file type. And if you do request this as a JSON file type, I don't think you're able to just parse this. Let me check. No, it's going to spit out an inordinately long list that contains sublists, and that's going to be a real pain. So what we're going to get here is the text from that JSON file, which you might think looks a little bit worse because it's just taken every single thing I've got here, year 1979 and so on, up to the end of the first year, and then I've got the second year and so on. This is text that looks like a JSON file. And so just to sort of be clear, you can parse this using a JSON Lite package, and I'm going to parse this using from JSON, and that looks more like a data set, right? So here I've got something that actually looks like a data frame. I guess let's make this as Tibble. Okay. Now again, if you can download everything using a CSV, download everything using a CSV. If you can't, well, you're going to have to do a little bit more work to understand what's going on in a JSON file and to deal with that. I think that's all I want to say about the water data set. I guess before, yeah, let me knit this, and then I'll talk a little bit about another data set that we might care about. This is NYC Water data using an API. Okay. Oh, I didn't actually do anything. That's better. All right. So now what we're going to get is the BRFSS data set. I think that's actually how you pronounce it. BRFSS is the, let me make sure I actually get this right. So here I'm going to cdc.gov. The CDC produces a bunch of data set. This is coming, yeah, like from cdc.gov. The interface actually looks very similar to what it was for the NYC open data set. They end up, I think, on the back end using the same structure for managing their API and making data sets available. But this is sort of a different version of the data that we might care, or sorry, a different data set that we might care about, and a similar process for interacting with it. Coming from a different group, again, it's the CDC. You can look at the data.gov, I think, has an awful lot of information available via APIs if you want some public resource, something like this. Now again, we probably could export an entire data set, but if this gets updated, and some of the data sets that we will work with moving forward do sometimes get updated, rather than just going to a website, clicking download and hoping for the best, we are going to work with the API here. So I'm going to use the same kind of thing, access this data set via the SODA API. We've got API docs and developer portal. I don't know what GeoJSON is, so I'm going to skip straight past that to a CSV, and I'm going to copy this. Let me see. Okay. So, same process, different data. So if I want the BRFSS BRFSS, and I think this is 2010 data set, we'll call it Selected Metropolitan Area Risk Trends, or SMART, County Prevalence Data 2010 prior. I guess I haven't talked through what this data set is, but I've got 134,000 rows and 23 columns that tell me things like the year, the location, the topic, the question, the response. So we get things like questions: how is your general health? The response: excellent. Was, let's see, so I've got here in Jefferson County in Alabama in 2010, the health status, overall health, how is your general health? An excellent response, had 94. Let's see, I've got crude prevalences. This is the data value. So 18% in this county in this year said that their health was excellent. And I imagine if I sort of went down, yeah, I've got here Jefferson County overall health. How is your health? Very good. I've got the data value was 30% said very good. So I've got now a bunch of different states and counties in states, and the proportion of people who reported that their health was excellent, very good, good, fair, poor, and so on. And this is a pretty big data set, and this is 2010 or prior, 2002 to 2010, county prevalence land data, behavioral risk factors analyze selected counties with 500 and more respondents, identify emerging health problems, establish and track health outcomes, and so on, right? And if you were going to use this data set, it would be really important to read through probably the methodology and certainly the glossary to get a sense of what really is included here. For now, I'm just going to focus on can I get this data set into R. So I'm going to take BRFSS 2010, which is just a fun thing to say. I encourage you at home to now say BRFSS 2010. Good work. So I'm going to get from that API the data set that I'm interested in. And let me first sort of check that this works. It looks like it is. It's giving me a CSV, year, comma, location, comma, the other stuff. It's giving me all the data that I was interested in. There is also the response information. Status 200 basically means that, yeah, this worked. And I'm going to just see, can I just parse this and hope for the best? Yep, looks like a CSV, looks like a tibble, looks like everything has worked. Tibble, 1,000 rows and 23 columns, year 2010, location. How is your overall health? Excellent, 18.9% in Jefferson County in 2010. Okay, so that's the good news. The bad news is, by default, well, I guess, like when I say that's the good news, what I mean is I am able to access this data set from an online resource using a couple of lines of code, and it's giving me the data set in a way that I want. And if this were the kind of data set that got updated pretty regularly, if, for example, we were sort of keeping track of health code violations in New York City on a rolling basis, or reported crime incidents on a rolling basis, or some other thing where data are being collected and then uploaded on a rolling basis in real time, more or less, you would need to use an API rather than just going to a place and clicking on it. So great, we've got some infrastructure that allows us to do that. And when I say that's the good news, I mean that's actually some pretty good news. I'm happy about that. The bad news here is that I have 1,000 rows in the data set that I've gotten, but over here they say there's 134,000 rows. And to figure out what's going on, you sort of do have to spend some time. I'm going to open, I think, the developer docs. So let's see. In here, there's probably some information. Let's see, getting started with a soda consumer API. I am going to open this. Again, I'm sort of digging in to some of the stuff that happens here. I'm also here, download and export. Want to grab this data set in bulk, you can use the soda QL paging parameters to iterate through a data set. That's starting to sound a little bit better, right? All right, actually, yeah, this is probably what I need. So paging through the data is sort of like, I see the data, I click next, I see the next data, I click next, I see the next data, and I click next. So the Socrata API request will return a large number of results rather than get everything all at once, which might affect either your application or their server side. You can sort of scroll through one batch at a time. Often an application will show the first few results and then load in the next results, such as clicking next. All right, that's sort of what we're talking about here. You can page through two query parameters. You can limit you can affect the how many parameters, sorry, not parameters, how many objects, how many rows are returned at a particular time. And then you can say, I've already loaded the first 1,000, now give me the next 1,000. And it says here, in this, that parameter, the limit, number of results to return, has a default value of 1,000. That's why I'm only getting 1,000 rows. Okay. There are updates. You can have a maximum of 2,000 if we were dealing with the Socrata API 2.0. And if you're looking at 2.1, this is unlimited. So potentially I could ask for 10,000 at a time or 100,000 at a time, or I could start sort of scrolling through multiple pages to get all of the data that I'm interested in. So I'm gonna very briefly illustrate how this might work, because we haven't gotten to a point where we can talk about sort of iterating across multiple things. I'm just going to say, how can I actually, how can I use these query parameters in my own use of an API? Okay, so the thing that I've said now is I want to send a request to an API and have it send me back some data. And the request that I'm sending is being structured using get. So get is saying, ask this API for this data set. So let me just double check what happens in get. There is config equals list, and then there's this ... further named parameters such as query path, etc., passed on to some other stuff. Okay. So that's actually kind of what I need here. So query, path, other things are parameters that APIs use to modify the request that you're making. You can specify a particular path on the server that you want to use, and you can update the query. And so here when it says the query parameters, I need to do something with the query parameters to make this work. And I'm going to see if there's anything down here. All right, so here it looks like query, the option that I might use. If I can specify this as a list where maybe a parameter is here. Actually, I haven't run this. What happens when you ask Google for that ham? Let's take 30 seconds and find out what happens here. Oh, well, something. All right, I'm not going to figure that out right now. Anyways, back to the BRFSS data set. I know that I have query parameters, and it looks like I have to structure this as a list. And I know that the query parameter that I'm interested in is $limit. $, meaning something completely different than it would in R. $limit is the query parameter that I'm interested in changing from 1000. So let's try here to set up query as a list where $limit, and I'm having to put this in quotes. This isn't in quotes, but this $sign at the beginning I feel confident would drive R crazy. So let's say $limit is equal to 5,000. And then hopefully what this is going to do is make that same request to give me the rows of a data set, but instead of using the default 1,000 rows, it's going to give me 5,000 rows. And here, let's see, that worked, right? So I've got now 5,000 rows, same beginning of my data set. Other things look to be about the same. And I could probably increase this to 50,000. This says it's unlimited. So if I wanted to get all 130,000 rows, I could do, say, 150,000 and ask for all of that data all at once. And I probably won't do that right this minute just because I don't want to spam that API, right? But let's just sort of check. Yeah, that looks like it worked. And I've got the first 5,000 rows of the BRFSS data set. Okay, so let me knit again. And then I'm going to make a couple of comments. All right. So this is BRFSS data. Okay. All right. So a few different comments. I think the first one that I'm going to make is some data aren't so nice, right? So all the data that we've played around with up to this point, BRFSS, NYC Water, even this, we had to extract 3 different vectors and then pull them together into a data frame. This was a table at the outset. All the data that we've looked at so far are sort of nicely structured and easy to pull together. Even when you do get something that's back in JSON, it's really just a question of converting it to a tibble, at least what we've seen up to this point. So let's look at Pokemon. So there is, if you're interested, a Pokemon API. So let's see what the Pokemon data might look like. And I'm going to get from, let me go to the course website. I've got a link to this. Pokemon API. All right, so here, what would happen if we looked for Pokemon 1? Okay, here, is it going to let me copy and paste that over? Not quite. I can sort of see, oh, direct link to results. Yeah, here we go. So if I get this, here is sort of the resource that it's going to spit out. This is all of the information that the Pokemon API has about the first Pokemon. It's got abilities and nested within abilities. It's got keys and abilities and overgrow and a URL that goes along with the first ability. There are forms and nested within forms. There are these things. There are 20 items in the game indices. There are different versions. We've got sprites. Okay. Back and front, female and shiny. I'm hoping that if you're a Pokemon person, a lot of this stuff makes sense. Maybe it does, maybe it doesn't. It is grass type. All right, so if I wanted to get this data, I can. And the point that I want to make here is if I just sort of take all of this, what is this going to return for me? It's going to spit out something. And let me see what happens if I try to extract the content here. It's giving me a long structured collection of output that goes along with all of those things that I just talked about. So we've got all the different information is listed here. And if I wanted to do something useful with this, I would have to spend some time extracting the moves, version group details, method, something, right? Like I would have to do something with this data set because it's just a more complicated structure than a data frame. And so when I say some data aren't so nice, this is sort of an extreme example where there's a lot of complicated stuff going on. Even in simpler cases though, you can end up with structures nested within structures, nested within things, and figuring out how you're going to convert that data into something you can use, something like a tibble, often is accessing the data is the first part of that problem. So we're going to look at these Pokemon. We're not going to worry about this too much, other than to say, if you get this data and you look at the name, that's pretty easy. And if you look at the height, that's pretty easy. And if you look at, and I know I'm using the $ here, don't judge me. If I look at abilities, I end up with, gosh, just a whole bunch of stuff, right? So here, the data are complicated, and how you interact with it is getting tricky. And that's about all I'm going to end up saying about that. I am going to close. I guess I'll knit. Let's see, close thoughts. So while that's knitting, I'm not going to type anything or write any code for the closing thoughts. I guess what I want to sort of point out to you is that it is easy when you are scraping data or accessing data from an API to make requests that end up being unreasonable. So to be clear, each time I have knitted this, it has gone and asked the BRFSS server to send me back 5,000 rows of data. And that might not be something that I want to do every time. And I've gone to the NYC and asked that server for that data every single time. And I've gone to IMDb to get the Star Wars HTML, and I've gone to this URL to get that data. So just by knitting, I'm sort of sending out requests to servers all over the world and asking that data to come back. And so if you're going to end up using a data set a lot, very often it's helpful to have one R Markdown file that says, here's how I accessed the data and processed it. And then any other analysis you do might be in a different R Markdown file that just accesses your processed data so that you don't have to go to the internet every time and ask for data to be brought in. In the BRFSS example, I've limited this to 5,000 rows, and that's not too big of a request. That's probably like a megabyte of data-ish. But if I was downloading the full data set, that could easily be, a 10 megabyte CSV file every time I download it. So when I say sort of like be careful, be responsible, be reasonable when you're doing this, sort of in the back of your mind, remember that each time you're running one of these, you are actually accessing a website and downloading a file. And if you accidentally did that a whole bunch of times, you could end up crashing a server. You could end up causing an issue. We have, I have, in the past when I've wanted to like get reviews for an Amazon product, been like, I'm going to download HTML for 1,000 Amazon pages, and after about 50 of those, Amazon says, it looks like you're spamming us, and we're going to go ahead and just shut you down on this. So you just stop it, right? You do have to be reasonable. You have to sort of be aware that although you're inside of R, you're interacting with the internet in the same way that you would if you were sort of working with a web browser. So beyond that, I think this is a useful time to sort of both take a step back and realize that you can access data from online resources. This is also a time to step back and say, gosh, I could sort of look through data.gov and see if there are any data sets that are interesting to me. I could look through some other publicly available resource. I could look at NYC's Open Data Project and see what other data exist and how might I go about accessing those. We will see a couple of other data sets in future video lectures and other examples that have been accessed via an API. And on the course website, we often share the code that we use to access those data sets. And so I'll sort of point that out. Let's say, for example, here we have a version of the BRFSS data set, and let's say restaurant inspections. So here we've got restaurant inspections using the httr dataset and parsing stuff using JSONLite. This is a much more complicated way of accessing data, and maybe at some point we'll spend some time talking about it, but just sort of know that these examples are available, and other ways of accessing data online are also possible, and that's maybe a useful thing. And so I think that's going to end it for today, and thank you very much.